Now, so in your paper, you draw these two. And then you put a stick along this axis. You hold a pencil, put a pencil here along this axis. This is a pencil. See here. Okay. Now rotate this. Rotate around this pencil. 180 degree. Rotate around this pencil 180 degree. What will happen? This chlorine will remain in the same position. So I will show this. See how we have to represent all this. You draw a pencil here and then put an arrow like this, 180 degree. Okay. So now see, 180 degree means this bromine will come exactly on the opposite side. And this chlorine will remain in the same position. Remember, chlorine will be in the same position. Bromine will come to this side. So when you rotate something 180 degree, remember that front will come to the back, back will go to the front. Am I right? And my left will go to the right, right will go to the left. Right? Now see here. You can see on my hand itself. You can see on my hand. Oh, I didn't see it. Now see. No, right. Now see. This is the front. This is the back. This is right, left for me, or right for you, whatever is that. Now this is left. Now see, I rotate it. So right has come to the left, left has gone to the right. Front has come to the back, back has come to the front. Okay, this is the out of plane rotation. Out of plane rotation. From the plane, you are removing it vertically. See this. You can do another out of plane rotation this way also. Horizontal rotation. Is it clear? This is also out of plane rotation. But here also the same thing happens. When you rotate a molecule, the 180 degree, right will come to the left, front will go to the back. Okay, so rotation of a molecule. Oh, internet is very slow. Rotation of a molecule 180 degree. Okay, 180 degree results in right and left. Right goes to the left, left goes to the right. Left goes to the right. Similarly, front to the back, and back to the front. I can put this also here. Okay. And therefore, see here, the Cl remains here. This hydrogen is on the back side here. That will come to the front. and the iodine is on the back, front side here, this will go to the back. And now look here, compare this with the original molecule. See, the chlorine and bromine are matching. They are one on the top, the other is on the right hand side, but the other two are matching. So similarly, if you rotate in any direction, I will tell you this will never match. They will never match. Okay? Say for example, look here. Keep your hand on this. Hold the chlorine. Keep your hand. I'll show you. Here is a chlorine. See this. It's a molecule. This is a chlorine. This is bromine. Okay. Now, hold the chlorine. Rotate it 180 degree. Hold this chlorine. Along this axis, you put your pencil and rotate it 120 degree. Rotate 120 degree. Clockwise. Rotate it clockwise 120 degree. 120, not 180. What will happen? See here. The bromine will come to the place of the hydrogen. Hydrogen will go to the place of iodine. And iodine will come to the place of bromine. Look at it very carefully. And Cl will remain the same. So my iodine has come here into the plane of the board. Bromine has come to the front. And H has gone behind. H has gone behind. See what happens. The molecule is not changing. Simple rotation around a molecule will never change the molecule. It is just like I'm looking at you from the front. I'm turning around. I remain the same. I'm remaining the same person, whether I'm turning to the right, left, or front or back. Similarly, you can rotate a molecule. You can interchange the three different groups in this way, holding one of them intact. Now look here. Hold this iodine with your hand. You can exchange these three in this fashion. See here. You can bring the chlorine to the bromine side. At that time, the bromine will go to the hydrogen. The hydrogen will go to the chlorine. The molecule will not change. It is the same as they see here. I'll redraw this. Iodine. Chlorine, H comes to the top. Cl will come to the front. And bromine will go behind. Bromine will go behind. Is it clear? So all these are same molecule. This is not superimposable with the original one. So these are the operations which you can do with a molecule, by which you will not change the molecule. If you want to convert these mirror images, what you have to do is you have to break this bond and break this bond. and put them in the opposite side. You have to break a bond. Breaking a bond will make them a different molecule. So remember, enantiomers are different molecules. Enantiomers are different molecules. If one is to be converted to the other, one is to be converted to the other, bonds have to be broken. Bonds should be broken and new bonds have to be formed. And new bonds should be formed. Meaning, enantiomers have different configurations. Enantiomers have different configuration. Is that clear? So this is the basic concept of chirality. Okay. Now look here. There are different ways of representing a molecule. One way is what we have drawn here, the wedge dotted line structure. Wedge dashed line structure. Okay. A second one is this is one. Second one we have seen is Newman projection. Newman projection. A third one is Sohor's projection. Of course, in these cases, you should have two carbons, and this is a Newman projection. You know that we have seen it. Sohor's projection is something like this here. This is Sohor's projection. This or this. Just like a horse seesaw model. Okay, it's Sohor's projection. And there is a fourth way, it's called Fisher projection. Fisher projection. Fisher projection is this way of doing. This way. You have this cross lines. Okay. Now, if I put A, B, C, and D like this, this means that the horizontal D and B are pointing towards you. and A and C are away from you. A and C are away. Now look here. This is the Fisher projection. One second. Yeah, this is the Fisher projection. A, B, C, and D. And you can see here, these two are towards you. These two are away from you. What is in the plane? Only the carbon. Only the carbon. Remember, this is not Fisher projection. This is not a Fisher projection. But this is a Fisher projection. This is a Fisher projection. This one is a Fisher projection. This is a Fisher projection. Okay? This is a Fisher projection. But this is not. That means, if I draw a molecule in this fashion, it is always assumed that D and B is towards you. Horizontal lines, horizontal groups towards the observer. And vertical groups away from the observer. Oh, my hands are paining. Okay. I was writing on this board for the last 3 hours. Oh, now my hands are paining. Okay. We'll just, so horizontal bonds are towards the observer and vertical bonds are away from the observer. So that is the basic concept of Fisher projection. Okay. So in the next time, what we will do is we will play with this Fisher projection and try to rotate them. And I will ask you people to draw the molecules. Okay. So today we'll stop at this point. We'll continue tomorrow. Even if I'm late, please, even you can call me to remind me, please. Okay. Don't just put a message. If I'm late, please remind me and call me. Today I was having another class. So when that class was just over, I saw one of you just trying to enter. That was good. So that reminded me, in fact. Okay, sometimes I'll forget. Please call me in time and remind me. If I'm late, I will try to tell you. Just wait for 10 minutes or 15 minutes. I'll make all time. Okay, thank you.